Some languages, such as Visual Basic, have a special math operator for doing exponents. And in Visual Basic, that's the caret or shift 6. But C# doesn't have that. So if I have two variables, and this is really only one variable, x, that I'm concerned about, x equals 3, I want to find that value squared. And so I could say z is equal to x times x, and that would be the same as having it squared. But we want to have that exponent maybe to 10 times. And it can get kind of confusing if I have x times x times x times x times x times x and so forth. So fortunately, C# has a class called the math class. Remember, a class is simply a blueprint that creates instances that contain properties, methods, and may respond to events. So the math class contains some methods for doing additional, more advanced math operations. One of those is pow. This allows us to do an exponentiation operation where we're taking a number to the power of another number. So here, z equals math.pow. The arguments I'm passing to pow is 3, 2. The first number is the base number, and the next number is the exponent. So this is basically 3 squared, and z would then equal 9. Math class also has a few constants, one of which is pi, and we know pi is 3.1417 and so forth. And this will take it out pretty much to a very long number. If I wanted to find the area of a circle, and I know what the radius is 6.75, we'll say inches, I can use the formula pi r squared to find the area of that circle, and I could then do that in a statement of C# of area equals math.pi, that's our constant, times math.pow, radius, 2, so the radius squared. So it's pi times the radius squared. And that would show us what the area is, or put the value of area into our variable named area. There are several other methods that are part of the math class. So we have some variables a, b, c, and d. A and b are integers, c and d are doubles. So we already looked at the pow one. Take a to the power of b, or 5 squared, would give us the value of 25 for the variable abc. Another one that's really handy is square root. Now if you take something to the power of 0.5 or a half, that gives you the square root. So you could do square root with math.pow, but they have a method built in here of math.square root, sqrt. I'm going to pass it the value of c, which is 25. And you know from your junior high math, square root of 25 is 5. That'd be the value of ABC. We also have floor and ceiling as operations in the math class. The floor will return the integer right below the value or equal to the value. So in this case, d is 12.75. The floor of d is the integer value of 12. You notice it's returning an integer that goes into xyz. xyz is an integer variable. Same thing with ceiling, except here's going to take the integer that's the next highest integer, or that's equal to. So the integer above 12.75 would be 13. The math.truncate will simply drop off any decimal value of a double number or a float number or a decimal value. And here xyz is going to be an integer, is going to be 12. This would really be the same as doing an integer division by 1. Math.round rounds the value to the closest integer, either up or down. If it is 0.5, so I'm going to set the value here of d to 12.5, it will round either up or down going to the closest even integer. So in this case, 12.5 rounds down to 12, but if d was 13.5, it would round up to 14. There are some other methods in the math class where you can have it round differently, but that's the kind of the standard round. Just be aware of that little instance where it doesn't always round up at 0.5, it may round down. Then we have max and min, where we're passing it two values. So here I'm passing it a and b, 5 and 2. For max, it's going to give us the larger of the two. So xyz would equal 5. The minimum, or min, returns the smaller of the two. So in this case, xyz between 5 and 2 would set the value of xyz to 2. So those are some of the more common methods that we use in the math class. There are more we probably won't use in this particular course, but if you're doing things such as in geometry, or this comes in handy where you're doing some physics or working on games where there's collisions and laws of physics and angles. We have functions for cosine, sine, tangent, arc sine, arc tangent. And then for some scientific things, we can find logarithms of values. So let's go jump over and do a quick little demonstration using the pi and the pow to find the area of a circle. I've created a C# Windows Forms application. I named it 03 Circle Calculator CS, and I gave the form a title of Circle Calculator C#. So I'm going to bring in a picture box on the left-hand side. I created an image earlier in Photoshop that's 300 pixels by 300 pixels that shows a circle diagram and the diameter for that circle. So I know my picture is 300 by 300, so I'm going to go ahead and set the size of my picture box to be 300, 300. And it's a little big for my form, so I'm just going to stretch the form out a little bit. Want a little margin here, top, bottom, and left. And then I'm going to bring in my image. So I'm going to import this to the project. There's my image. I'm going to say OK. I'd like for this image to look like it's just on the background of the form itself. So I'm going to set the back color for the form to be white, so it just kind of all blends in. Then I'm going to take a text box, and we'll put a text box on top of our image. I'm going to set the back color of my text box to yellow, so it stands out a little bit. This is where I want them to enter the diameter. Let's go ahead and give them a default. So I'm just going to put in 10.0 as the default diameter. So pi r squared would be 100, and then times pi is going to give us an area that's related to the pi number. So we can make sure this is really working. And I always like to have my numbers right aligned in a text box. I might make that a little bit bigger just to have it show off better. So let's set the font to something a little larger. Maybe 14 point. That looks much better. Okay, then I want a button. We're going to name this button BTN Calculate. And the text of the button will be Calculate Area. I'll create a label that simply says Area. And then below that, we'll create another label. I'm going to delete the text there, but I want to set this label for the auto size to be false. And again, we're going to make the font a little bit bigger. This one I'll go 12 point. And we need to give this a name. So I'm going to call it LBL Area. Okay, so we have this text box we had for our diameter. I need to give that a name as well. Let's just call this TXT diameter. And for my label for the area, I'm going to go ahead and give it a border style. We'll give it a fixed 3D border style. Okay, so now I'm ready to calculate what the area is in my button. So I'm going to double click on the button to get a click event handler. We have a double value named r for radius. Actually, we'll go ahead and name it radius. Equals, I want to get the text value, that txt diameter dot text. I want to convert that to a double value, so put that in parentheses and then do double dot parse in front of that. And I'm going to divide that by 2, or 2.0. Okay, that'll find the radius. Then I need to find the area. And this was the statement we saw earlier. I'm going to use math.pi times math.pow. We're going to pass it the radius, and we're going to square that. And then finally, we'll show this in our label, LBL area.text equals, and we'll take the area, convert that to a string, so toString, and let's set this for 3 decimal places. So we're going to say N3, and my semicolon. That's our code. Let's test this and see if it works. Let's go ahead and test this. So I'm going to click the calculate area, and the area is 78.54, which is pi times 5 squared, or pi times 25. I think 3 times 25 is about 75. A little more there, so it's going to work out accurately. I was thinking 10 squared would be 100, but remember this is a diameter, not a radius. So I'm going to set this to 20, and we should give us a value of a little over 314 for our area, because it's going to be 10 times 10. And that's what we get. So it seems to work. That is how you can use the math class, in this case the math constant pi and the method pow, to do some calculations.